Hey everyone, my name is Sebastian. As Pei mentioned, I'm CTO and co-founder of DC Spark. As well, I'm involved in the development of Flint Wallet, as well as Milkmeet that you see on stage, and more recently a new company called Paima Studios, which is building blockchain on-chain games for Cardano. So what is Milkmeet? You might have heard of this term because Milkmeet released on Cardano a while back. And you might have heard of this layer 2 topic, and you might be wondering, well, what is a layer 2, what is a sidechain, and how all these things work. And so I wanted to take some time today to talk to you about what the work we're doing and what we have now and what we're hopefully going to be deploying in the future. So let's start by, what is the difference between a blockchain, a sidechain, and a layer 2? To make sure we're all on the same page. So you folks all know what a blockchain is. Hopefully you've used Cardano, that's a blockchain. So what is a sidechain? What's the difference between a blockchain and a sidechain? A sidechain is the exact same thing as a blockchain, except philosophically, it's instead of trying to be its own project, it philosophically aligns with an existing project. So it's not really a technical difference, it's a philosophical difference. So for example, for Cardano, Milkmeet is a sidechain for Cardano. And the reason it's a sidechain is because we associate with the Cardano project for this deployment, and we don't have our own token. So the base asset for the Milkmeet sidechain for Cardano, which we call Milkmeet C1, is ADA. So you can go between these two chains and keep your ADA as is. You don't need to go buy or sell any tokens to use it. So if that's what a sidechain is, then what is a layer 2, right? So the difference between a sidechain and a layer 2 is that the sidechain gives you more flexibility, but less security. So one way I like to describe it is we can put everything on a spectrum. So on one side, there's maximum flexibility, but lowest security. On the other side, it's maximum security, but lowest flexibility. So as I mentioned, sidechains is full flexibility. You can have whatever consensus algorithm you want. You can have whatever execution model you want. You can have whatever token you want, right? Now, on the other side of the spectrum is often what is called ZK rollups, where you have full security using mathematical proofs, but you have very low flexibility, because now you need to write everything you want in ZK circuits, which are very hard to write. Oftentimes, you have to use a programming language that's not easy to write, such as Cairo. Oftentimes, you have a lot of difficulty doing upgrades. Like if you want to upgrade your ZK circuit, this is also a very difficult task. So it's not a very flexible system, but you get a lot of security to go with it. So there's something in between called optimistic rollups that you might have heard of that's less safe than ZK rollups, but more flexible. The reason why is because you don't have to have everything encoded as a ZK circuit. You don't have to use this hardcore cryptography that's hard to upgrade. You can just use a concept called fraud proofs, which is you assume people are honest unless somebody does something incorrect, in which case you call them out and post a proof that they did something incorrect. So instead of having to prove the correctness of everything, so in the ZK rollup, you have to prove the correctness of every action. In the optimistic rollup case, you're just proving dishonesty whenever required. So you get faster performance, more flexibility, but obviously less safety. So Milkmeet, our goal is to become a layer 2. And what kind of layer 2 do we want to become? Well, we're actually trying to come up with a new kind of layer 2 that sits in between optimistic rollups and sidechains. And so we want more flexibility than optimistic rollups because we want to switch the virtual machine from Plutus to EVM. So it's a larger switch than typically you would have with an optimistic rollup. But we still want more security than a sidechain. Because as I mentioned earlier, oftentimes the extra flexibility is not something that you need. And so we want the added security for our use case. And so you may have heard that recently we're deploying for Algorand, a layer 2 version of Milkmeet. And you might be wondering, well, wait, so if they're deploying a layer 2 for Algorand, where's the layer 2 for Cardano? And so I want to kind of describe the difference between these two deployments so you understand where Cardano's at, where we're at as a project, and then later on we can talk about how we can close this gap and our kind of roadmap to get there. So how do we build a layer 2 like Milkmeet? You've heard me talk about how this is safer. You might be wondering, well, how do we actually make it safer? Why is it safer? And so to talk about that, we need to kind of take a step back and talk about what is the core value proposition of blockchain? Why is a blockchain so useful? And intuitively, you might think like, well, a blockchain is useful because we can all agree on the correct state of data. If you post a transaction to the Bitcoin, if it's a correct transaction, it gets on-chain. If it's an incorrect transaction, it gets rejected by the node. So it's a decentralized way of agreeing on the state of a machine. But that's not actually quite accurate, because although Bitcoin, it is true that it only stores correct transactions, that was not a requirement. We could have made a version of Bitcoin that stores both correct transactions and incorrect transactions all in one giant blockchain, sometimes called a dirty ledger. And in this model, when you're synchronizing a blockchain, like if you're synchronizing the Bitcoin blockchain, you would be synchronizing all the transactions, including the incorrect ones, and your local machine would see the incorrect transactions and just know to ignore them. Right? So it's like, oh, correct transaction, oh, incorrect one, just ignore it and move on. Right? And if you have this kind of model, you still end up with the same Bitcoin blockchain that you know today. Obviously, there's data waste because these incorrect transactions just blow the blockchain, but it did not take away from the value of the Bitcoin blockchain and the fact that we all agreed on the resulting state. So if the value of a blockchain is not agreeing on the correctness of transactions, then what is it? And something that a lot of people have been talking about is something called data availability. And what is this? It means that we can make the data that represents the Bitcoin blockchain available to anybody. If you want to synchronize the Bitcoin blockchain, no matter where you are in the world, there's some way for you to connect and get that data and get it on your machine. Even if that transaction was posted 10 years ago, 14 years ago, you can still get the exact transaction now on your machine. And that's really surprising because if you know anything about Web 2, you know that a lot of data does not last. Oftentimes you post a picture or you find a picture, and a few years later, it's magically gone, it's disappeared from the hosting service, or somebody closed a Twitter account. So the fact that we can have this data, have it available for everybody, have it available on a scale of decades is really quite the innovation, especially because it's all in a peer-to-peer way. So when we talk about layer 2, to bring it back to that, we kind of take this similar idea, which is, we want to have, for example, EVM running on Cardano. Cardano does not have EVM support, so what do? We say, OK, we'll instead of having the EVM on Cardano, represent the EVM state indirectly through, for example, transaction metadata. So imagine that you're a user and you want to interact with an EVM on Cardano. Instead of implementing the EVM in Plutus or implementing the EVM directly on the layer 1, you instead just submit data that it says, I'm a user of an EVM, and I want to send some funds from this person to this person. You don't actually execute anything. You just post this as transaction metadata. It does not execute, just lives on the blockchain. And then now if you want to synchronize the state of this layer 2, you would basically synchronize the entire Cardano blockchain, look for this transaction metadata that says it's an EVM transaction, and then implicitly rebuild an EVM state from that. And if you ever see a transaction that doesn't match, for example, Bob is sending to Alice, and Bob doesn't actually have enough tokens to make this transfer, you can just ignore that data, right? And so with this mechanism I just described, we basically use the fact that Cardano is a decentralized blockchain that we can have available, that we can download from anywhere in the world, and we can get the data from many years ago and still have it available to our computer, and use this to basically build another machine on top of it, like the EVM. So now that we've described a layer 2 system and how, more specifically, roll-up, if you ever heard the term roll-up, this is this kind of system I just described, the kind of layer 2 I described. Now we know how roll-up works. Well, why don't we do this on Cardano now? Why are there no roll-ups on Cardano now? And there's a few technical problems. Obviously, from a technical perspective, the challenge is a bit harder than I just described. But there's also kind of a unique problem to Cardano, which is that how do you post data to the Cardano blockchain? Right? So earlier I was saying, oh yeah, we just post the data, we post the transaction to the Cardano blockchain, post it as transaction metadata. But you cannot just post megabytes of data to the Cardano blockchain. Right? Cardano has very strict limits on transaction metadata, on transaction size. And transaction metadata cannot be accessed from smart contracts on Cardano. So the data that you post would not be able to be accessed by a smart contract if you said, like, OK, let's do the kind of a proof, like a fraud-proof setting I described earlier. You can't actually access that data. Well, there's actually a different way of posting data on Cardano that can be accessed from smart contracts. called inline datums, and that was added in the Vassal hard fork that happened only very recently. But this functionality is actually very expensive on Cardano. So if you want to add data as an inline datum, there's something in Cardano called the min UTXO requirement. You might have heard this, especially if you're familiar with NFTs. And this will make the cost of adding this data to the Cardano blockchain prohibitively expensive to build a layer 2 solution. So now you see that we have these two ways of posting data on Cardano, but the limits on the amount of data you can post and the cost of the data that you can post on this chain is fairly limited. And that's why you don't see kind of layer 2 solutions thrive on Cardano as you can with other chains, such as, for example, Ethereum, which is, as you know, is significantly philosophically more OK with posting large amounts of data to their chain, even if it means their blockchain bloats up to 1 terabyte in size, as it is today. So obviously, there's trade-offs to everything, right? If you take the Ethereum approach, obviously, it's easier to build rollups, which is why you see so many rollup layer 2 solutions on Ethereum today. But the trade-offs is it means that if you want to try and synchronize an Ethereum full node today, you're going to be synchronizing your node for a very, very long time. So obviously, it's a whole trade-off. But the reason that the Ethereum ecosystem was OK with making that trade-off is because posting raw data is obviously much cheaper than executing code, right? So if you've ever seen Ethereum gas problems where during a peak, the gas cost would skyrocket, this is mostly caused by smart contract usage. And so if they can take the smart contract usage, move that to a layer 2, and then from a layer 1 perspective, you're just posting data, then this makes the chain much cheaper operate, especially under the assumption that storage is relatively cheap. So hopefully this kind of gives you an idea of layer 2 solutions and why some blockchains have more layer 2 adoption than others. And also for Cardano, we'd like to eventually support layer 2s as well. But also we have to handle these data requirements carefully to make sure that we maintain decentralization while also enabling these new functionality that enable more efficient execution than we might have otherwise. And so that's why, for example, for Milkamita, we're deploying for Algorand as well as Cardano, because for Algorand, they already have this technology required for layer 2 solutions. And for Cardano, we're obviously working on a very ambitious roadmap here as well. And we're hoping that as Cardano continues to advance and more features added into Cardano, that we can eventually add all the features that we want to build a full layer 2 system. But one advantage that we have of having a sidechain on Cardano instead of a layer 2 is that a layer 2, if you think about it, it inherits the properties of layer 1. As I mentioned earlier, we're posting data to the layer 1. And that's how you're advancing the state, this implicit state of this virtual machine. And so if the Cardano block time is 20 seconds, and if the finality on Cardano is probabilistic, that means that your layer 2 also has block times of 20 seconds, also has probabilistic finality, and this is not necessarily desirable, right? You might want a system that is compatible with Cardano, somehow connects to Cardano, but has different properties for finality or perhaps different properties for block times. And so the fact that Milkamita for Cardano is a sidechain means that we were able to get it to a block time of 4 seconds with instant finality, which is obviously a different set of properties from the Cardano main chain. So sidechains definitely still have their advantages, and they will never go away because the flexibility allows you to have different trade-offs for different situations. And that's why, for example, Mamba, the system that IOHK is creating, is like a sidechain SDK for Cardano. That way people who need different sidechains with different properties for different use cases can easily spin up sidechains to meet those requirements. And so hopefully it gives you an idea as to why we're doing sidechains and layer 2s and kind of parallel as an industry. You see many successful sidechain projects and many successful layer 2s, and these are not necessarily replacements one for another, but rather two different technologies that have their different trade-offs. So hopefully that gave you an idea of overall the big picture, what we're trying to solve, where we're at in Cardano, why we're taking the approach that we have. And I wanted to take the last few minutes to just talk about some of the upcoming stuff in our roadmap. So obviously, Milkamita is doing pretty good overall. We're about 10% of Cardano's TVL at the moment. So there's a good amount of adoption of the system. But obviously, you can always build more. You can always build better stuff, cooler stuff. And so some of the stuff that we're working on is, one, we're working on wrapped smart contracts. So you might have heard this from our original roadmap. But one thing that we want to add for developers in Cardano is the ability to call EVM smart contracts from the Cardano mainnet. The reason we want to do this is because a user of Cardano ideally should not need to even know that they're using EVM, right? If you have to take your ADA, send it to Milkamita, use a smart contract there, move your ADA back, this is quite a lot of user friction. And for a lot of applications on Cardano, they don't necessarily want EVM for their entire application. They may have a Plutus app that supports a wide set of features, but there's some specific functionality that they need that already exists on EVM, and they want to just leverage this existing solution, or maybe this is easier on EVM, so they want to leverage an existing solution. So they want to have an entire app that's all in Plutus, except for one specific part that leverages Milkamita. And to do this, we want to basically have this concept of wrapped smart contracts. So as a developer, you can have your app all work in Plutus, and then this one button, when the user presses it, instead of making a Plutus transaction, from the user perspective, it looks like a Plutus transaction, but what actually it does is it takes the Plutus transaction, creates a message, passes that to Milkamita, executes the transaction on Milkamita, takes the results, and brings it back to Cardano. So from a user perspective, it'll feel a bit slower because obviously it has more steps for their transaction, but it doesn't feel like you left the Cardano universe, and that's really a much smoother user experience, and will hopefully help developers mix and match different programming languages where they need. So that's one of the cool things that we're working on, and the other thing that we're working on is liquid staking for Milkamita, which will allow you to keep earning your staking reward while using Milkamita. So if you ever use Milkamita, you might have noticed that one of the issues is that you lose your staking rewards when you move to the sidechain. And it's unfortunate because it means that any DeFi application used on Milkamita needs to give you at least 4% APY for it to be competitive versus the staking rewards you would get on the base chain. Now, there's no reason it has to work this way, right? When you're moving to Milkamita, it's not like your ADA disappears from the main Cardano network. And so we're working on a system that allows you to continue to accrue your staking rewards on the Milkamita sidechain while you're using dApps over there. And what's interesting that it also allows, that's interesting for developers, is that it also means that EVM smart contracts can actually earn staking rewards as well. So just like how in Cardano, if you have a successful dApp on Cardano, you may be able to earn staking rewards from your successful dApp. So, for example, JPEG Store delegates the ADA that is in their contract state. In the same way, as a Milkamita dApp, you would be able to get the staking rewards of any ADA that's in your contract. So it's kind of an interesting incentive, for builders to build out their ecosystem. And so these are kind of two, new things that we're working on for Milkamita C1. And obviously, we have a lot of stuff in store. Like I mentioned earlier, one of our partners, Paima Studios, is working on blockchain games for Cardano. And part of that leverages Cardano mainnet, but part of the application also leverages Milkamita. So hopefully we can have this kind of system for building on-chain games as a layer 2 for Cardano, and continue to leverage some of the technology that Milkamita is kind of trailblazing, to keep improving Cardano, to keep attracting builders to Cardano, and keep improving the Cardano ecosystem. So that's all I had for today. Hopefully this kind of give you an update of Milkamita, how it works, how it's different from sidechains, what we're doing in other ecosystems, and kind of our roadmap in the future. And so I thank you for your time. And if you have any questions, we have a DC Spark booth at the event, so you can check out our booth and ask any questions. Or if you see me walking around, definitely just let me know and ask any questions you have. Thank you.